Hi guys, we'll wait for I think 2 more minutes till then we can start the session, I suppose. Okay, shall I start then? Just say yes or no if. Yeah, hi. I'm sorry. So the thing is, so Chiti had taken my session the last time on Friday, and I'm going to take Chiti's session today. So we'll be continuing the same. We'll be continuing with the same order from the next week. So that's me on Friday and Chiti on Tuesday. This was just something that we had to work with for this week. So, anyways, I will start with the first question. Yeah. So yeah, for the people who are new to the session, I'll how it works is I'll show you a slide with the questions and the options given, and I would prefer if you can type your answer on the chat box, and if there are any questions regarding that, you can speak up. Um, yeah. So people are saying A lot. So also people remember this is a hypothetical case. Don't go with what you what you might have studied about the hummingbirds. So yes, I think we have got 6, 7, 8 A's and 2 C's and 1 D. Interesting. Nobody thinks males and females can have separate migratory timings. Nobody heard of that before this?
Yeah, I have heard it. I have heard it because I have seen documentaries saying about the pelagic birds. But here it is about the reproduction, and reproduction is an energy-intensive activity or life stage, and it's not just winter but any season according to the birds, because there are some birds which also reproduce in summer. So it's a season based because of the plenty food of availability of food, and so I think these.
But
Yeah.
how is this graph representing the migration?
Sorry, what?
How is this graph representing migration so that we can conclude on the B
Oh,
part?
when I said migratory timings is basically the males and females come to the particular migratory breeding ground at different times, is what I meant.
No, I understand that part, but what I'm trying to say is that the question is more about in this particular hypothetical case, right? But from this graph or given information, I cannot make out whether the male and female are having actually different timings.
So this is a hypothetical case, and yeah, of course, reproduction is an energy-intensive activity, and males and females take. The B is basically that males and females have separate migratory timings, so basically they come together only for a particular season. That's winter. So that's what I meant. Is that a good
No,
enough?
no, he is asking, sir, sorry to interrupt. He is asking the graph which is given along with the question.
Yeah,
It doesn't serve the purpose for the option B. That's what
it does.
is.
No.
I mean, how he is not able to connect it. Can you
How
just
how how does it
how?
represent a male and female here? Sexes.
So how would the
It is
birds
not given actually.
how would the birds breed if the males and females are not together? Is what I'm saying.
No, I agree to that. So it's just saying that winter is the reproduction season, which means male female are together there.
Yeah,
Obviously, this is a fact.
yeah.
But
Not a fact.
from
It's a hypothetical case, but yeah.
yeah, whatever.
Hmm.
So, but from spring, summer, or autumn,
It
I
could.
cannot make out whether male female are together or different at different places. It's just indicating me resting and foraging. But what is male's part, what is female's part, that is not clear from the
So
graph.
what was your answer, Sachin?
A. Reproduction is an energy intensity
So you
activity.
don't think winters could provide abundant access to food?
Oh, obviously it could provide,
Yeah.
but only reason that I did not select D is because this graph did not give me clear indication about the male female.
All right.
Whether okay, the clear question is whether all birds or migratory birds have different timings for male and female.
Yeah. That's not true. I mean, some
Yeah,
of
that's what I'm saying.
yeah.
From this graph, I am not able to categorize this graph for species which is having different timings for migration for male and female.
All
So
right.
that's why I did not choose B or at least D.
Sure. Yeah. But the main point of the question was to introduce you to what individual level energy budgets are and how are they quantified. The
Mm.
question was just a way of putting it. So,
Yeah,
yeah.
I mean it does give good information. At least I didn't know that males female may have different migratory timings.
Now you know.
Yeah,
Yeah.
yeah.
All right. So I'll move to the next question. The answer I'll show all of the above. The answer is D if people hadn't got it by now. I'll move on to the next question. Yeah.
Excuse me.
Yeah, go ahead. Go ahead.
what was the previous question in relation to like which birds specifically?
No, it was a hypothetical case, Govin. There is no bird like that, or at least I don't know of any bird like that. It was a very hypothetical case. You wanted a bird like that? Do you?
Simply wondering.
No. I don't know. I don't know if a bird is existing that has wintering. No, actually, there are birds, but yeah, I mean, I can tell you like bird species with different different options working for different birds, but I can't tell you birds which have all the options working for them. So yeah, I mean, anyways, the question was hypothetical just to introduce you to what the entire, like how the energy budgets are calculated. So I suppose it made that point. Is that okay, or should we discuss more on this?
Well, that's fine.
Yeah, okay. Thank you. Anyway, so second question.
Excuse me, sir.
Yeah.
Doesn't all the three incorporate? I mean, like, should be instead of none of the above, should be all of the above. Because none of the above
Yes,
doesn't
sir, all
suit you.
the-
All of the above, all of this actually causes some of the other offsetting the endotherm case.
So in a laboratory setting, you think variables cannot be controlled for environmental changes?
We can just guess, sir, but not exactly, no, sir.
No, variables.
If we have to recreate the exact
No,
settings,
variables. I'm just saying. So suppose one variable, I take temperature. Do you think temperature cannot be controlled in an environment? I mean, in a laboratory setting?
yeah, it can be controlled.
Can be, right? Stress levels in animals cannot be controlled in an environmental setting.
How can we control stress levels, sir? It is up to the organism to react to it, no, sir. Like,
Yeah, but
we don't know how will they react. Even though
but
if we are
laboratory-
given ambient temperature and everything, atmosphere,
Yeah,
we
but-
will never know how the organism react, right?
But it can be controlled for a bit, right? You can keep the animal overnight. There is a provision of reducing the stress levels, can't you?
Okay, I wasn't aware of that, sir, because I'm not that much aware of that.
So when you're doing experiment, you pick the animal. Either you do it immediately, but then that's the time. Or if you're catching a bird immediately from the wild, then the stress levels are the highest. So usually what people do in these settings is keep the animal overnight, let it habituate to the environment, and then conduct the test. So that means the stress levels have gone down. Basically, what they are looking for is reduce the stress levels. So
Okay.
basically, it can be controlled.
Okay, sir. Sorry, sir, I wasn't aware of all these things.
I mean, that's the whole point of this. That's okay. So what's the answer? Oh. Did you guys give the answer? So Govind says B.
So within a
Yeah, Sachin, go on.
Well,
let Govind continue. I'll talk later.
Oh, I didn't hear Govind speaking anything. Govind, were you saying something?
yes, I was.
What is it?
Well, regards to option A,
Huh.
variables may be controlled, may be controlled in an laboratory setting, but all the variables can be taken into account in a laboratory. So there may be some variables or factors in the environment which
I know, but I haven't said all the I haven't said everything can be controlled. I said some variables can be controlled. I didn't say all variables or no variables. I just said variables can be controlled. Right?
Yes, sir. And in regards to option C,
Hmm.
sometimes depending on the bird, this can take time to decrease. Sometimes it may take just a day or two. Sometimes it may take
Yeah,
months.
controlling is not basically reduce it to zero. Controlling is basically reducing it. Right? Or increasing it.
Oh,
Could be any ways. It
yes,
can.
sir.
Okay? So, I mean, it's also some of the words that I've used. I know I'm not the most. Yeah, Sachin,
Yeah,
you. Yeah.
I have a question related to the point B, which mentions that the metabolic rate for individual birds. So I wanted to understand whether within a species can there be a wide variation in the metabolic rate of the birds.
Yeah, same doubt, sir.
Yes, they can be. I mean,
So
okay, within humans, do you think there are different metabolic rates for different people?
yes,
Yes,
obviously.
yeah.
So
I mean, that's
correct.
as so.
Mm,
Why do you think the animals wouldn't have the same thing?
right.
Yeah.
Sir,
So
but
that
this is a experimental model. They would have thought everything, right? Like if they gonna handle the organism, whatever organism
That's
they are
true. What do you
using.
do? Do you work on Drosophila or something?
What's sir?
What do you do? Do you work on Drosophila rats or something?
No, sir. I am a housewife.
Okay.
I did my masters in microbiology, but
Ah,
that was a decade ago.
you must have worked on something, no? What was your model
Uh,
species?
I no, sir, nothing. I was like, no models.
That's
Yeah,
okay. That's okay. That's okay.
Drosophila. Yeah, Drosophila we did, sir.
Yeah, yeah.
Yeah,
So
we discussed.
they have germ lines and all. I understand, but within there are like Drosophila strains also which have like something more, something less, right?
I'm sorry, sir, I lost you, sir. Can you just
I mean,
repeat it again, sir? Yeah.
so there are. I mean, I understand when you're working on Drosophila, you pick like one particular strain or one particular lineage of Drosophila.
Yeah, yes, sir,
I'm not
yes, sir,
exactly
yes,
sure
sir.
of that. I have never worked in labs, but within, I
Okay.
mean, you can have different strains, right? One strain with
Yeah,
high
yes, sir.
metabolic
Yeah,
rate,
yes, sir.
yeah. So that is
Yeah.
experimental. But suppose I want to study grasshoppers in my backyard, and this is backyard of my institute. I go and pick them up and bring them. Don't you think a species within the same species can have different? I mean, it doesn't have to be.
Yeah,
Um,
yeah,
yeah, this is doesn't
yeah.
have to
I
be all
understand.
Drosophila or all rats, which
Yeah,
are.
I understand, sir.
Yeah, yeah.
Yeah, I got the point.
So, yeah, I'm just trying to show you what all can be done or what all has been done. So I'm just basically Anusha study. If you remember Anusha Shankar's talk, you guys remember Anusha Shankar's talk,
yeah.
right? Yeah, yeah.
Yes,
So
yes, sir, yes, sir.
yeah, so she is studying hummingbirds, but she's studying them in the field, but she's still carrying out experiments on the bird. So it's not a laboratory setting; it's a field setting, but still there are like some kind of experiments that happen, and so when she's collecting them, those birds, there is a high chance that the individuals within those laboratories would have varying metabolic rates, right? Because they are all from the wild,
Right.
right? So that is the point. So this particular question has been taken from Anusha's paper. Sorry, I haven't mentioned the paper, but one of the papers of Anusha, it'll come in the next slides. So you may get to know which paper I'm talking about. But what she's trying to say. So answer is B if people haven't got it yet. Yeah. So what she's trying to say is so her point being, so if you read the paper thoroughly, you'll see that why she doesn't want to work on hummingbirds in a laboratory setting. What she says that all the models that have been done or have been created for energy budgets in laboratory settings, they don't incorporate individual variability in metabolic rates because of this reason, because I mean it becomes difficult. I mean if your studies don't take into account the wild population, So that's the whole point of this question.
Sir,
Yeah.
is B option B is the reason for option B is because the sample space in the laboratory is very small, right, sir?
Yeah. Govind, you're not very clear. Can you repeat what you said?
The reason for option B is
Yeah.
that the sample space of the species in the laboratory is very small, right?
No, no, no. That's not the laboratory. The reason for just a sec. I'll come back. I have someone on the
I
door. Just a
I
sec.
think, yeah, Govind, I think instead of sample space being small, it would be unpredictable, right? Because we might assume some model for the physiology or the maybe the overall metabolism or other
Yeah, but the
parameters for a
model,
bird,
but the
right?
model should have, all these models they have come up. They would have some credibility, right? They would have been taken into account. Okay, a wild
No,
population they might not have taken into account, but metabolic rates as such they would have answered those questions
no,
because
no. I'm okay. I agree to your point, but the point is that if I take some hummingbird in the laboratory for testing or measuring the parameters, and within it itself, it has different metabolism rates. So from my field experiment, I might expect torpor to go at some so and so temperature or so and so time, right? But if some other, if the captured hummingbird has some higher metabolism rate or something, these parameters may change. Or if it is a lower metabolism rate, it may change. So
yeah,
unpredictability is the factor instead of being sample space being small.
yeah,
That's
I
what I
got it,
was thinking.
Thank you,
got it.
Sachin. And Rusbe, you had a question. You've been raising your hand for the last 3-4 minutes. Do you want to speak up?
Yes,
Yeah.
Jobin sir, even I'm not very sure how B is the answer. So would this hold true if we were not referring to the specific paper on hummingbirds that you mentioned? Or would this be true in any context or only in the context of that paper this holds to be true?
I think definitely that paper, but I think any context it might hold true because if you, mm, I mean the point, the when you're, I mean that's the whole. I mean, of course you can take strains of different metabolic rates of Drosophila and study and say okay, I mean they have different variable, but they, I mean you might not have like a gradient. You might have like metabolic rate with this particular range, metabolic rate with this particular range, metabolic rate with this particular range. So you'll have, but if you want to look at a gradient like a constantly increasing or constantly decreasing, then probably you might have to go with the wild population. But yeah, I can't go into details because this is certainly not something that I have done in my in my work.
Okay,
Yeah.
but just to understand better, so what is the advantage in this case of a wild of individuals studied in the wild? So is it just because it would be a much wider, bigger sample size?
Much wider sample size, much truer to what is seen in the. I mean, it would be much truer to what is
Okay,
seen in the nature, right?
okay,
I mean, laboratory settings can sometimes have. I mean, although
Yeah,
you
much more authentic, much more authentic, realistic, real to
picture,
the real settings,
yeah.
nearer to the real settings.
So that's what Anusha was trying to get to.
okay.
I to add on something to Rusbe's question, I think, I mean, as an answer, Rusbe, my analysis or thought process was more related to the parameters or the options given rather than whether it is an empirical answer or not. Meaning, metabolic rate is one part, so there could be another n variables which may or may not be controlled in laboratory setting. But if we consider these three options, one is mostly the temperature, humidity, and all these environmental factors that we may be able to control in a laboratory. Point C is about the stress level, which I was thinking that stress level is a effect, okay, to the other factors. Obviously, predation is out of question here because in laboratory you may not have predation pressure. So I was thinking because of environment like temperature or something, if it can induce stress level into the bird similar to what it does in the nature, that's what I was thinking. So that way I was more inclined towards point B.
No, no, no,
That
no. I mean,
no?
no, no, sir. No, I don't think that. Uh, I mean, it's not to induce stress level in animals. I mean, yeah, I'm not sure if animals in wild are always all the more like with high stress, but I can be really wrong. So, yeah, I mean,
Okay.
yeah, but glad that we are discussing on these points. But yeah.
I mean, so taking the same line that Sachin had, if
Yeah.
I look at all the three options and I'm looking at a laboratory experiment vis-a-vis or versus um, a study done in the wild, then obviously I would think that it's C, which is the correct answer, because that's typically what would be the I would think the most likely kind of outcome of studying specimen individuals in a laboratory setting.
No, yeah.
And
I mean, so suppose I'm studying an animal which is like thoroughly, what is that word? It, so basically, it's
domestic,
breeding in a laboratory and it knows the setting.
okay,
So it's
Docile
not
docile
docile,
domestic,
organism.
not docile, docile,
Docile organism.
habituated.
Habituated.
Yeah,
okay,
thoroughly habituated to the laboratory setting. Some animal, it would have like a low stress level. It's only the wild animals that you are immediately caught which will have a high stress level. Even then, it can be controlled by keeping it overnight, and by the morning when it becomes a little more habituated. I mean, this part I know because I have worked a little bit on grasshoppers, but mm, yeah, I mean, so in the papers have said that keeping an animal overnight or something. I mean, those are the things that even Anusha has done. If you read the paper clearly, to reduce the stress level of the animal, they don't catch the bird and immediately, measure the levels of whatever metabolic, basal metabolic rates and stuff like that. So,
okay. So
yeah,
basically, the answer is it's much more to do with the smaller size, sample size, rather than the fact that they are being studied
laboratory setting.
in a laboratory setting.
Yeah, but since hummingbirds are not model organisms like your Drosophila or mouse, I mean lab rats, it's not possible for people to get like high number of birds in an area near the. I mean, but yeah, I
Correct.
mean that can also happen. You never know. But anyways, glad that we have a discussion on this. I'll move on.
Sir.
Yes, who's this? Sorry, Govind. Yes, go ahead.
Yes, sir. I just had one small doubt, sir.
Yeah.
Uh, in a way, in a way, B includes both A and C as an answer, right, sir? Since
How do you say that?
the well, the metabolic rates of an individual can vary depending upon the environmental factors and the stress level. And a laboratory setting cannot always include A and C. There will always be a few differences or a lack of factors when it comes to A and
What
C.
was
So
what was the last point, Govind? Could
B.
you? What was the last point? Sorry.
Well, and the laboratory will not always take into account all the factors of the environment, just like
Uh,
in option A.
yeah.
And if a bird becomes too habituated, then it will have a lower stress level compared to the wild birds, right, sir?
Okay.
So I felt that in a way option B includes both A and C, since these two factors of A and C can alter the metabolic rates of a captive bird compared to a wild bird.
Okay. So should I have added like models don't usually incorporate individual variability in metabolic rates or something like that? Would that have been better?
I would say
Well,
B option you could have changed it into all of the above.
No, I don't think all of the above because environmental changes, environmental factors, variables can be controlled in laboratory. Not all, but some. And stress levels can be controlled in a laboratory setting. Not all, I mean, not entirely, but can be, but some of the individual variability cannot be incorporated in most laboratory settings, especially if you are studying wild animals. I mean, especially if you're studying something like hummingbirds. But anyways, we'll move on from this question. We are hanging on to this question a little longer than usual. Third question is on your screen. So you guys are reading the reading material that have been posted on the NPTEL portal.
Yes, sir. Yes, sir.
Okay.
Slow, yeah.
Okay. And have you been reading about Anusha's work? What is the paper that she worked on, or even Sahas Barve's work? What is the paper? Because since Chiti did a session before this, I didn't want to repeat anything that she's already done. So I mean, my most of my questions are from her work and Sahas's work. So yeah, that's why I'm asking. Okay, so everyone, I got like some 6 answers. Let's see what the answer is. Basically, laboratory setting. It was easy because this is animal responses to environmental changes in field. I mean, I don't think you'll have to take laboratory settings in account. This is like a yeah. So basically, what this question was trying to say is there are 3 things that you take into account when you are looking at models of animal responses to environmental changes. One is the individual variation, like I said, like variability in metabolic rate, or variability in the masses, or variability in the life stage of the animal. And the other is the behavioral flexibility, how flexible the animal is, and that also varies a lot in the wild. Some animals are neophobic, neophilic. So neophobic is, I mean, I wouldn't go very detailed into behavioral part because I'm not an expert in that. But neophobic is something where the animal is afraid of a new thing in their environment. Neophilic is basically they're more curious and they come closer to a new thing in the environment. So animals can have a spectrum of behavior between these extremes. Then obviously real-time environmental changes has to be taken into these account. So real-time is the thing, is the key to it. Laboratory setting is basically useless over here. So I hope people got this. The next question. Are we still connected? Say yes or no. I mean, I'm not sure. No, there is no response from anyone.
Yeah.
Oh, yes, we are.
Okay, okay. Also, I mean, the I mean, I did some of the questions in the first part where I was just taking questions from what has been taught to you. When I showed it to Suhel and Raja Jayapal about, oh, this is the questionnaire and this is what I'm going to present to you guys, uh, the response or the feedback that I got from them was, try to incorporate other papers. Don't just limit yourself to the questionnaire, or don't just limit yourself to the study material that has been given, or to the lecture. So that's the only reason why I'm diversifying a little extra, so that there is little more that you can learn from here rather than what is already being taught in the classes. So I suppose, um, if I suppose that's okay.
Sorry, anything which we get to learn, it's okay for us.
Yeah, because
We get to learn, it's learn.
yeah, because I'm not sure. I mean, if people are, I mean, people just want to brush up their things which might come in the exam, because nothing from these things can come in the exam, is what I understand. They won't ask you something very out of the box kind of a question. So I just want to clarify right now. So, but everything, I mean, even reading a simple paper, like, I mean, say for example, if you pick Anusha's paper or Sahas's paper, there are certain things that you might come across, or there are certain things that you might have to know beforehand, which is not taught in the class that you are attending in. So that's the only reason why I pick particularly this question. Okay, so when
Sir, 1 minute.
Yeah.
In this question,
Ah.
isometric is mostly related to musculature, right?
No.
Tightening and contraction of muscles. So isometric means.
No.
I mean, I'm not aware of bones, but yeah, for the size, when it comes broadly in general, if it is said, allometric is used for the size of the organism.
Yeah.
But isometric is for musculature, right?
Is also used for size of the organism, or anything actually, even muscles. But yeah.
Okay. I'm confused between A and B, sir.
Okay.
But I have gone with my gut sense at A.
Okay.
But I need a clarity in
So
that.
basically, did you understand what is happening over here? I mean, between the quoll, the tiger quoll, the small animal, and the elephant, what is happening over here?
Their sizes
Comparison, sir.
their size have been scaled according to the environment they are in.
Yeah,
And
but
what
is that
the
all?
real-
Is that all? Something else is happening?
Yeah, proportionately the size is scaled, sir, so
Are
that
you
it
sure it
serves
is
the purposes.
proportionately? I mean, if I, are you sure it is proportionate?
Yes, sir, because it's a small organism, its needs are different. That's why the muscular, whatever the bone structure is according to its use, sir. And whereas elephant, they are very bulky and everything, and their bone structures are
Thicker.
in related to what they are actually, how they live their life there.
So bones are thicker, you're saying, because of the weight of the animal.
Yeah, the way it is going around, the way it lives, it's a natural history
So
makes
that is
it.
allometric basically. It's not an exact increase in the, like, if I had to, if it was isometric, basically the same animal, the skeleton would have been for elephants. I mean, including their tusk and everything, but the bone thickness would be the same basically if it was isometric. But that's not how things work in the nature. It's more allometric most of the time. So so based on the weight of the animal, the bones have also thickened, and yeah, that's all the point of this question was. So it's the answer is
Sir,
yeah.
Does it? Okay, Govind, you go. You go.
but I didn't quite understand your explanation of isometric, sir.
So Govin, I couldn't hear you. Sorry.
He's saying that he missed out on isometric.
Oh, you missed out on isometric.
Yes, sir.
Okay, so basically, so if there was an isometric increase or scaling for quoll to elephant size, like quoll size to elephant size, the skeleton would have looked exactly the same, except the tusk would have been added and stuff like that. But do you see that the whole, there is a slight difference in the proportion? The bones are much thicker compared in elephants compared to the quolls. You can see the rib bones thicker. You can see the legs are thicker. You see that, right?
Yes, sir.
Right? I mean, when you see them next to each other, you can see that there's a difference in the. It's not just a scaling up, like a direct scaling up. I mean, I just didn't pull it like that and made an elephant. No, it's not. I mean, not the nature, but that's what allometric is. And if it had been exactly the same, it would have been an isometric. Even in human beings, for example, when a baby is born, the if you measure the proportions of hands and legs and the eyeballs and everything, you will see that the ratio of the of all the limbs to the body is quite different from what adult human being has. Like even the growth is allometric sometimes. Are we clear? Are we here?
Yes, sir.
Yeah. So suppose I mean just for an example, I mean this is one such trivia. The eyeballs never grow in size. I mean once you're born with this eyeball, the size of the eyeball always remains same. So you will see that the babies have larger eyeballs and hence they look cuter and stuff like that. But once they grow up, I know, I mean, some people grow up cute, but not that's not the point. Some, but as you grow up, the size of the eyeballs remains same, but that's not the case with the size of the limbs. The limbs grow. Hands and legs grow taller and longer, same as the torso, head. So those are the things that allometry takes into account. Isometric would have been like a baby just expanded into a larger 6 foot baby. Do you get the difference over here, Govind?
Yes, sir.
Yeah.
But tiger poles are marsupials. Is that taken into account?
Sorry, what?
Tiger poles are marsupials, sir. Does that also play a part?
Uh, I mean, that's why it was the skeleton. Not exactly, but no. I mean, the allometry and isometry doesn't have to, since they are in like, no. I mean, yeah, I can't tell you about that. But you're getting into too much technicality, which is way beyond my grasp.
So on the same line, I have two questions. One is related to the eyeball size that you said does not change.
Yeah,
What is it called?
I don't know. Yeah.
Is there any terminology for that? I mean, compared to the scaling that happens for other parts, muscles or the bones or limbs, whatever.
Allometry.
Sorry.
Allometry.
I do not know whether there is that there is a terminology for
You
the
can look it
things
up,
that
yeah.
do not grow actually or change their shape throughout the life of the species.
I think you can look it up, but I feel,
Okay.
yeah.
And second part, so if I understand correctly from what you have explained, allometry is more related to comparing different species versus isometry can be related to the more
No,
related to
no, no,
same
no, 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 no,
species in
Uh,
lifetime, something
uh,
like that.
no.
yes, sir, 1 minute. I would like to say this
Yeah.
here. What I have understood from sir said, isometry is like, the drawing. If you have ever drawn, you draw scale models of something. Okay, like
Correct.
if you big home is there, you draw a scale model in 200 is to 1, 1 is to 200, 1 is to 300, like
Right, I understood.
that's the isometric. Allometric is completely it doesn't conform to a particular thing. It is on its own. It is not confined to a particular set of parameters. It is not exact shortening or enlargement of like xerox copy ke tarah. Like you don't how to say, you don't expand or contract the thing. It is on its own. It has its own set of conditions which dictates how it is, like how it
Yeah.
come and manifests.
I mean, what I'm meant to say was that I cannot apply isometry to two individuals from different species. Is that correct? Will that be
Yeah,
a correct understanding?
yeah. You cannot, even
Okay.
in the same species, you cannot apply isometry.
Yeah, isometry is. I don't know if it's there in nature at all. But Deepti, you wanted to say something. You've raised your hand.
Yeah. How does allometric relate to the study of birds? In what way it is help us knowing more about the birds?
Okay. Oh, the interesting question. If you have read Anusha's paper, like I said, I've been taking only from Anusha's paper, nothing from outside.
Yeah, yeah.
If you have read Anusha's paper, she's talking about mass difference between the larger hummingbirds and the smaller hummingbirds, and how some variables within the birds don't change with the increase in the mass. But anyways, we'll get to that later,
Yeah.
I suppose. But yes, it is related to birds in some sense. Don't worry. Also, birds also show
Okay.
allometry and isometry. Yeah.
No,
Sorry.
I don't think so. But when
No,
we talk
they
about the
don't show isometry,
allometry,
but they do
we
show
have very small.
Sorry, Deepti, you're saying something. Sorry.
Yeah. Even the birds are from the smallest to the biggest size, right?
Yeah.
So allometric do something for this size in the
No.
birds
And, but it does definitely does for the.
because allometric means in general, allometric means the characteristics of the size growth of organism or else it may be animals or whatever it may be, right?
Yeah.
So I just wanted to know how it works for the birds.
Oh, how it works for the birds.
Yeah.
It's the same way.
That,
I mean, birds when they come out of the eggs, if you compare the head size and the body size, the head is much bigger than the body. You can see any chick,
yeah, I understand this when you explain me regarding the eyeball, right? But according to Anusha asked whatever she has done, she was telling us that when the birds go to the higher elevations,
no
to the
no no
Himalayas or to the mountain range areas,
no
does the growth matters there? Does
no.
allometric do something even at those places?
Anusha's paper is not on the elevation migration of the bird. Anusha's paper is on the hummingbirds, which live in the high elevation. They are like the
Uh,
residents.
okay, I don't know who's that, but I read this. So does it matters?
Yes, it matters. Can we
Yeah.
come to that point?
So it depends upon the environment also, not electric, but it depends upon the environment also. The size, the bird size or whatever it is, it depends upon the environment when it comes to birds.
Uh, uh, am I the only one who can't hear Deepti properly?
No, sir. We are not able to
So
clearly comprehend what she's trying to say. It's a
Yeah.
lot of.
Deepti, so
yeah, maybe
you're saying that environment affects the size of the bird, or what are you trying to say? Sorry.
yes, yes. Yeah. See, along according to this question, the thicker bones, whatever it is there, the size, everything depends upon the allometric way of characterization. But when it comes to the birds, they go to different places, they migrate. Even at that time, it will be the same or it different. It changes the behavior or not.
No,
The
no.
growth or whatever it is, does it change?
Um, while the bird is migrating, so suppose within the lifetime of the bird, so suppose the bird migrates in 2021 from, say, I don't know, Amur to Africa, I think the allometry doesn't change at that point or at that time. But this is more like the growth of the animal, like from the chicks to the adult, or this is more applicable when you are looking at the size of the animal, intertaxa size comparison, or within the same species the inter age size comparison. That's what allometry is looking at. It's not like within the same species, within the same individual, it doesn't change like that.
Okay. Yeah, I
Yeah.
got it. Thank you.
Okay.
Thank you. Thank you. I got it.
All right.
Excuse me, sir.
Yeah.
Can I ask Sachin sir about his option? He had said P, high
Yeah.
metabolic rates.
Yeah.
According to the question, the metabolic rates should be flexible enough so that either they can minimize or maximize. We can study that. If it is high, we can't study minimizing effect. So it can't be the option also. Right? So it has to be low body weight. I mean, fat storage again. It depends upon the metabolic rates. So I don't think P is an answer for that.
I mean, it was a right way of coming to the answer. Like sometimes, if you don't know the answer, you can do one of those. What is that word for it? Where you pick out the wrong.
Elimination.
Yes,
Elimination.
exactly,
Yeah.
exactly. Pick out the wrong answers and come to the right answer. But yeah. But it's also written, right? It's a very high mass specific more metabolic rate in hummingbirds.
Then mass means fat storage or body weight.
Body,
Either can go, no, sir.
body weight.
Yeah,
Mass
but
of
the storage also fats also affect the body weight. Also. Like if it has high, the body weight will be high.
Yeah.
So it's like either A or C. Both can be.
No, but when we are saying mass specific metabolic rates, that would mean the smaller animal would have a particular metabolic rate, and I think it is positive over here in hummingbirds. Mass specific metabolic rate, the rate is positive. The smaller animal. No, it's actually I forgot. But anyways, we'll come to the next question. Not in the next question. It's the last question. But the formula is given over there for the metabolic rates. But yeah. But basically, what I'm trying to say is, keep based on the mass,
Sir?
your metabolic rate would change. Yes. Who was this? Govind. Yes.
I didn't quite understand the answer to this question.
The answer wasn't given yet. Yeah. Yeah.
Oh, I didn't understand the question. Sorry, I phrased it.
Okay. So Anusha wanted to check. I mean, the what she wanted to check is given in one of the questions that is coming in this thing, but she was looking at how she was looking at basically torpor, and she was trying to understand if do you remember the first question? You have different activities for which birds allocate certain time and energy.
Yes, sir. Yes,
Yes,
sir.
sir.
So, so basically, over here, she was trying to see if torpor and the other activities that the birds do, how are they allocated. So she wanted to take a model, take an organism, a model organisms, where it's easier to look at the loss and the gain of energy without any kind of confusion. Okay. So what do you think would cause a confusion in such an organism? Like gaining energy and losing energy, like without any kind of break in between, which confuses the experiment. We only have like a few days with the animal. So the fat storage, right? Okay, I think I
So
lost
the
you.
reason for
So basically, if an animal can store fat, that would mean the energy that it's gaining is basically increasing the mass of the body, and it's not coming out as the true metabolic rate. Okay.
sorry, sir, I didn't hear you. I didn't hear you clearly. Could you repeat the last point?
Okay, so we are basically looking at an animal where you can measure the energy that it's gained. So that would be basically how much food it has eaten or how long it has eaten food. Then you can measure how much it is losing energy. So that is basically time allocating the different kind of activities it is doing. So animal was perching at one point. The perching is equal to this much amount of energy. So perching time is 2 hours. So that means 2 hours into x will give you the amount of energy spent on perching. Then it was hovering for a few hours. So hovering would have a certain energy that is spent, etc., etc., etc. Right? So we can do that, right?
So basically, it's measuring the energy consumption
Govind,
each time without.
you're not audible.
Sir, can you tell me now?
Yeah, we can hear you a bit, but can you repeat whatever you said?
So basically, it allows for real-time energy consumption measurement
Yes,
without
yes.
taking like energy batteries into account.
Yeah. And hummingbirds, except when they are migrating, they have low fat storage. So they don't store. I mean, most birds are like that. Except if they're migratory, they don't store fat like that. So hummingbirds become like a model organisms. So this is basically there are two things over here. Hummingbirds have high mass specific metabolic rate, which means there is a relationship between the mass and the metabolic rate of the bird, like which is very tight. Like the relationship is very tight. It's not a loosely based relationship. And the other is it has a low fat storage. So the confusion of whether the energy was gained, but was it stored or was it released? That confusion is not there. It was always energy was gained and energy was lost immediately after this amount of work done by the bird. So that's why hummingbirds were a model organism in the study that was done by Anusha. Are we clear?
Okay, sir.
Yeah, I mean, don't dwell on the technicality. I mean, obviously these questions are not. I mean, they're not intuitive enough. They are intuitive, but they're not intuitive enough that you could immediately get the answer. Nor are these questions coming in the exam or anything. These are just questions that I put up so that I could. I mean, there are things to talk about the whole. The whole bird and metabolism and stuff like that, which is the course that Anand was taking. So just a little more information about the whole field. I mean, there's a lot more to it than what Anand could teach in that one particular hour. So that's the only that's the only motto of this whole session. I don't want yeah I mean, I'm not looking for all right answers from you. I mean, just so that there is discussion, that like in the first two questions there was a lot of discussion, so I like that. I mean, probably you can discuss a little more, but yeah, I mean, just that I'm not the only one speaking. That's all I want. All right. Oh, people have answered. Sorry, discovered 5A. Rusbe says B, Harini B, Govind B, Niveta B. Yep. So everyone knows what a keel sternum is, right? What is the technical term used for it in birds?
Carina.
Yes. And carpometacarpus is basically the fusion of metacarpals and carpals together, so they make carpometacarpus, which was never in bats to begin with, so it cannot ever retain that. And keel sternum is a very specific bird thing which came to support the breast muscles for the flight. So definitely it's not all of the above. It is phalangeal digits, which most of you said like they were right. So I'll move on to the next question. I don't think we have to discuss so much in this.
Huddling. D.
Lakshmi, please, could you type? I just don't want everyone to. Sorry, I mean, Lakshmi, no, nothing, but while you're answering, just answer.
I'm sorry, sir. I was answering in the keyboard only. My keyboard got stuck. That's why I had to.
All right.
The key was got stuck. The letter key. That's why.
I mean, I don't discourage discussion. But
Yeah, I understand, sir. Only for technical reason I called out.
Sure.
Sir, I have a doubt with the option B. If it is hot temperatures, they tend to roost in, not the roost exactly, I was not going for the exact term, but they take
Shelter.
In a shelter, right? So flying away is not an option. Panting also is not an option. Since some birds do, but that not birds do, the mammals do. But panting, I have not seen in birds, as such in my experience. Being on the legs, in fact, all the things are like completely bizarre, not related to birds. Huddling is the only one which is related to birds, and that too. I don't seem the options are correct or something. Sir, there is something off about the options.
Okay, I think if you're talking about the panting part, we'll get to that. Peeing on the legs, I haven't included in the any other questions. So I can talk to you about that. Flying away is also something that I can talk to you about, but I'll not talk about the panting part right now. Yes, the answer is huddling. Definitely, birds don't huddle for hot temperatures, but they do huddle sometimes. But uh, for a for a hot climate, they don't like. I mean, when the temperatures are hot outside, it's not a particular behavioral adaptation that birds take. I mean, birds adapt to. So basically, panting. I'll talk to you about that. It is present in birds. It's called something else. Then flying away, sand grouse's example. It basically flies. It doesn't fly away, but it flies from the hotter region to the water body to bring back. And there are birds also that fly away from a particular region. And then peeing on the legs. If you have seen storks, like what are the storks? The painted storks and all. They have this particular habit of if you notice their legs very clearly, you'll have these white substance collected on their leg. So that's basically it.
Guano.
Shravan, yes.
Yeah, they defecate their guano onto their legs.
Yeah,
The
guano.
pink legs turn to white.
Yeah,
The painted socks.
Is guano the right term? I'm not sure, but yeah. Anyway, so I thought guano was used for bats, but yeah, I mean,
So panting
Even for
is
the
seen
last
in cormorants, sir.
yes, it is seen in cormorants. Yeah.
Yeah.
So basically that white thing protects at least the leg part from the heat. So that is also seen in birds. Huddling is not something it's seen in birds as an adaptation to a hot temperature. So that's the answer that I was looking for. Anyways, the next question. This is a very technical question. If you know, you know. If you don't know, it's okay. But at least give me a ballpark figure. Like, what do you? Are there two options that you'll go for? Are there three options that you go for? I mean, at least give me a ballpark. Like, you want to pick B, C, D, and B, C, and D both, all of three. Then, yeah, sure. So, according to Gopi, you're saying that. Okay, yeah, sure. Rusbe has C.
Sir, I think it's after the KT period, sir. Because after that only the birds started
You're thinking
diversification.
it in the right
So it
direction.
and maybe like B or C, sir. Both can be. I have doubt for B and C both
What
because
when
they are.
can you Google right now when the KT extinction
Actually,
event happened?
66 million years, sir.
Yes.
okay, okay. Okay, fine. A is the answer, I guess.
Then there was this. What is that called? Adaptive radiation.
Yeah. So how does adaptive radiation determines related to carotenoids? I mean pigments on the.
Oh, that I don't know. I mean, that's something that happened in the past, and I'm definitely not an expert to ask these questions too.
So the answer is A.
Yeah, answer
Okay.
is A.
Okay.
So basically, black and
Sir,
brown.
another.
Basically, what the question is saying that black and brown melanins, the animals were definitely black and brown in color before the KT extinction happened, but after KT extinction, there was this whole burst of energy, according to some papers. This Thomas et al. 2014, which was there in one of the reading materials that Anand has shared. So I think you should actually read those things also, and also if there are guest lectures and all, you should go and check out their papers as well, because yeah, I mean, usually the guest lectures are very young scientists, so they have like a less number of paper that you can refer to and read through, and I mean, but the others have a lot of papers because they've already become like associate professors, assistant professors, so it might be very difficult to collate whatever all of what they have done, but that's one suggestion that I have. Anyways, the answer is 66. So there was something that happened after the KT extinction, that there was this burst of colors in the birds. But there are some theories which also say the dinosaurs were colorful. But I mean, I don't know. I don't know. But yeah, Govind, you were saying something.
Yes, sir. I was trying to say that flowers had newly evolved in the Cretaceous period, and after
Angiosperms.
only
Yeah.
after the yes, and after that, you had certain things like fruits and other colorful uh, uh, sources in nature where carotenoids could be found from. So I'm guessing the availability of carotenoids became much higher after the KT extinction.
Okay. Yeah. Probably you're right. Yeah. But I'm glad this discussion happened. I'll move on to the next question. An easy one. Deepthi, did you raise your hand in the last question or something? You can speak up if you want to. I mean, I see your hand raised. That's why. Okay, nine people are saying B. Some are saying D. B. Yeah, I mean, this is a simple one. The answer is B. Uh, I think, I mean, it was one of the questions that Anand, one of the topics that Anand had discussed. So I think I'll leave it at that. Pneumatization is a trade off. So when the pneumatization was happening in the bird bones, it was both making it light as well as not brittle. So otherwise, it will break easily. So that's the whole point. So, by the way, as an example, if you want like an analogy of how pneumatization helps, so like Eiffel Tower has a lot of the triangular, the like it like a structural engineer.
Rebars, sir. It's
Yeah,
called rebars.
yeah, a structural engineer would actually be able to explain much better how triangles are very robust in, and they don't yeah, they're very sturdy in their how they stand. So it's something of the similar, like a lot of people say that Eiffel Tower, the whole idea was taken from the bird bones, but yeah, that is something, I mean, it's just a analogy that one can think of, but I don't think you should take it seriously. But I'll move on to the next question. Again, a very simple answer. All right. So it was
Is the spelling actually RHAMPO
oh,
or?
I'm sorry. I didn't check it when I was writing it down. Is it RHA?
Yeah.
All right then. Then I'm sorry. But it's definitely not ampo theta. All right.
RHAMPOTHCC.
Okay, I'll change that later. Thanks. Who was this? Govind? No.
Sachin.
Sachin. Thank you, Sachin. Yeah.
What was the answer to the previous question? I wasn't able to. I was outside. I couldn't. I lost connection for a second.
Oh, Rampothika. CA. And Sachin mentioned that there was a spelling mistake, so it was RHAMPOCA and RHAMPOTHECA. Rampothika. So there's a take to this. Leucism is basically, the answer is eye color. So what is generally said is, because albinism is basically, you cannot produce melanin at all. So what it does is, your eyes will also be without melanin. So there would be less chances of you to be able to control light entering your eyes. At least when you're opening, when you have like lids open. So that most of the albinistic individuals usually die off very early before they even attain maturity because of these things. So leucistic individuals are usually what you see around, lot less albinistic. I hope that's okay.
So, but actually, differentiation is very easy. Now, albinism is a complete lack of pigmentation, and leucism is there will be patches here and there, irregular patches of the actual original color of the bird. So, it can also be like A. How can it be only B? B? Hello, sir. Yeah,
So
because the see D is an eye color, which eye loses completely even the color in albinism. Okay, yeah, that's there, but why can't be A also?
yeah,
Then
true. It can be A as well. Very good. I mean, yeah. You pointed out the right thing. It can
I'm
be, yeah.
I have just one point on that. What if some birds are actually, I mean, some species of birds are actually just black and white in patches?
Yeah.
And if albinism has actually, I mean, those
yeah, then
only
there
those
will be
patches are gone.
no. That's what I'm saying. Albinism is complete lack of any pigmentation. Even if
Right.
it is a pied organism, a PIED pied organism, black and
Yeah.
white organism with patches, if you can see the patches, then it can't be albinistic, right?
So what I'm trying to say is that if in case of maybe leucism, only those patches are gone, and then both the birds are same white. So will you be able to distinguish based on those colors only? I mean, the body colors only or not? That's what I think the gist of this question is.
So um, then it
You
won't
get
be
my point?
generalistic, no? It will be very specific, right? All these questions are
No,
generalistic,
maybe
right?
generalistic, yes, but
Because pied birds losing colors is very rare because already they have only one
No.
or
That's
two
not true.
pigments.
That's not true actually.
they do.
Yeah, because I just recently saw white-bellied, drongo, pied white-bellied drongo in Tirupati. So, and it was there. Like a lot of people have. If you Google Tirupati bird, you'll find that mentioned there.
Yeah, I was there, but I didn't see that.
It's there in one of
Yeah.
the parks. Very easy to see.
Okay.
Yeah.
Okay.
So that's not true actually what you said, but
Got it, sir. Got it.
all right. Anyway, so let's move ahead. This is, this is one of the questions from the talk. Might as well do it. Yeah, I think people who have actually heard Anand's talk would know that he kept on mentioning about the unidirectional flow of the air and two two globules. What was the term he used? Anybody?
Sacs, air sacs, two air sacs.
Air
No,
sac.
no, that air globules or whatever you're saying is the correct one.
Yeah. So yeah, two air globules come inside, one stays longer, then it is released, and the other takes its place, and then it's released. So basically, yeah, the answer is the third one. Or was it? Yeah. Anyways, I'll move on to the next question. Yeah. People were talking about panting in birds.
Yeah, this is seen in cormorants and usually in the waders more. Those which lack oil in their body surface, they have to pant and they have to dry themselves and they have to.
I don't know
And
about the oil part.
Not only just the oil, but it's like they reduce their body temperature by doing this.
Yeah, because
panting.
For example, like in yes, for example, like in pelicans, they
okay.
Yeah,
have the gulab
cormorants.
pouches, which you can see. Yes,
Cormorants also have that.
yeah.
So the answer, what is the answer, everyone? B. B. Oh, okay, everyone said B.
Yeah,
Okay, so
gulab
the
pouch.
it was not globule, it was boluses, BOLUSES. So the last question, if people remember what I said, so
Okay.
the air ball, the air
Yeah, boluses, air
boluses,
boluses,
yeah.
yeah.
So yeah, the answer is jugular, no, gular fluttering. I have a video after this. Probably it would be much better to see it. Do people remember the bird that was that is seen in the um, in Kutch that nests in the open? It's one of I forgot what it's called. It's a ground bird. It'll nest in the ground, and
You mean Hopula?
Hupulak. Yeah, Anand has also mentioned that it does gula fluttering. So it's not necessarily water birds, as Lakshmi was mentioning. Hupulak is a very dry area, arid zone bird. So they also do gula fluttering. I think it's mostly to do with the absence of canopy on the head. So them not being able to take a shelter because of the absence of any kind of shelter. So pelicans, darters, they mostly sit on the open water, and yeah. Anyways, this the next question. I suppose everyone knows why the answer is C. Can someone tell me why the answer is C?
Radiocarbon.
No, why the answer? I mean,
No.
why was the
Uh,
pink-headed duck? The it was not give. I mean, the feathers were not used for any other thing but C. Raman spectroscopy. Radiocarbon, is that the reason? Radiocarbon. I mean, are you talking about the?
maybe
It's
because of
extinct,
the
right?
prisms, prisms they resemble the feathers. That's why a principal mechanism of Raman spectroscopy. lends itself into understanding the pigmentation.
Scattering of light, actually.
Yeah, scattering of light.
Okay.
The
Okay. I don't know the
proper
technique.
wavelength.
I don't know the technique also, but the simple
It
answer
was
that
extinct, right?
yeah, it was extinct, and thus it was difficult for anyone to hamper the bird for any kind of testing, like the extinct bird, the birds that are not extinct. You have them in the museum, and you can take a piece of their feather, a piece of their muscle, with certain kind of a permission. But this bird being extinct, it was not possible, so they had to do Raman spectroscopy because it was it wasn't invasive, so it didn't allow. I mean, you don't have to like pull out a feather or something like that. That's the simple reason I was looking for. I think you guys got too.
What was the reason, sir?
Oh,
So need not disturb the specimen.
yeah, it's less
Just
invasive.
yeah.
Less invasive,
Yeah.
less invasive.
Yeah. All right. This is too technical. I think I'll just tell you the answer. If you don't get it, it's okay. It's too technical. I can't even explain how it is. But Shravan, you want to say something?
Oh, sorry. I turned my mic on. Sorry.
Okay, the answer is yeah. I'll just go ahead with this answer. There is like a description to it. This is the question that Chitti helped me prepare. Just a sec. I don't want you guys to see the next question's answer, so I'll give you the description later on somewhere. I was just trying to find the thing on my phone, but I can't find it. Anyway, so basically it has something to do. I mean, if you want further information, I think you can Google UV signal in passeriforms or something, shortwave sensitive cones and all. So yeah. Deepthi, you want to say something? You have your hand raised.
No, 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 no.
Okay.
Sorry.
All right. So, what the paper is saying, the small endotherm's nighttime energy management in its natural habitat is more affected by torpor bout duration, which is linked to photoperiod, than by temperature. So, that definitely says that A is true. The energy management is not affected by the temperature, so it can actually happen across a varied range of temperature. People agree with that? Then,
Can you,
yeah.
can you repeat it, sir? Can you repeat it?
So it's saying that it's not affected by temperature. The torpor duration is not affected by, sorry, not torpor duration, but the endotherms, the nighttime energy management, whether it's doing torpor or not, is not affected by temperature, it's affected by photoperiod. Photoperiod is basically how much day length and the night length is happening every day. So it's definitely hummingbirds are able to save energy in torpor across a range of nighttime temperatures. So whatever the nighttime temperatures, I mean not whatever, but within a range, whatever the nighttime temperatures are, hummingbirds are able to save energy in torpor. Then the other is it may have sufficient physiological flexibility to tolerate climatic variation. So based on what is being said in A, one can say that B is also possible. There is a sufficient physiological flexibility of the bird to tolerate like a wide range of temperatures. At least climatic variation could mean temperature. Uh, C is something that I said is not true. Individual entering torpor was not correlated. Probability of engineering, not correlated with mass. Actually, it is correlated with mass. It's something that the paper says. Like the larger birds. Okay, I mean, the larger birds have the smaller birds, since they are very small and their surface area to volume ratio is very high. Yeah, very high. It becomes difficult for them to control their energy losses. So that's why they go into torpor more. The probability of a smaller bird going into torpor is much higher than the probability of a larger hummingbird going into torpor. So that's C, which is definitely false. So the answer that sits right is D, both A and B. Are we, did we understand, everyone?
Sir,
Yes, Govind.
yes, I understand, sir, but isn't it possible that torpor, the process of torpor is what allows B? Would hummingbirds be able to withstand flexibility in climatic variation in without torpor?
No, no. So basically, the question is whether it is doing torpor or not. How is that affected by? I mean, it's not affected by temperature, but maybe probably affected by photoperiod. That's the whole. That's the whole statement that the study says, and thus, uh, what it what what it means is there is a wide range of temperature that the hummingbirds can save energy in torpor within that wide range of temperature, and sufficiently it has like a good physiological flexibility to tolerate some temperature variation, temperature ranges. So A and B are basically the same, and C is something that is, yeah, uh, there is there is a correlation which say between the mass and the ability to, or not the ability, but the probability of doing torpor, which C is actually negating. So that's the whole point. It's both A and B. Okay. Silence. Yeah. Okay, I think everyone's getting the answer. Yeah. So this is a section from his paper. What does it say? Like, I mean, I hope everyone, I mean, even with or without science background, can read some graphs. So just wanted to ask you what they think about this graph. Can someone tell me what do you understand from this graph?
Maybe this shows the elevation of the bird as the elevation increases. Their downy feather section also increases so that it helps in the withstanding of the higher climbs, cold climbs there. So
Okay.
that's what I feel.
All right. Higher the elevation, higher the proportion of downy feathers.
Yeah, it's a proportional, directly proportional. The elevation is higher. There will be much more downy feathers to be seen on the
Okay.
bird,
Okay.
which helps them in insulation.
Okay. Just randomly asking, why couldn't it be opposite? No, it doesn't. But everyone knows, right? The elevation is the independent variable over here, and the proportion of downy section is the dependent variable. I mean, I don't know if people do get confused with that. Independent variable which affects the other variable is often on the x-axis, and everything else, like, which is the dependent variable, the variable that gets affected or that you're trying to test if it gets affected, is usually on the y-axis. So some trivia that I just said. So yeah, basically the downy feathers increase in proportion.
Sorry for interruption. Can
Yeah.
you just repeat the trivia, sir? Like,
Okay.
I just got cut.
Okay, so independent variable, which is a variable like temperature, precipitation, which do not change because of animals. I mean, people generally study these things thinking that they affect the animal behavior or animal morphology or anatomy or something like that. So, elevation, temperature, precipitation are all usually independent variable. Usually. And then there's a dependent variable, specifically in animal studies and all. Then there's a dependent variable, some variable that you're trying to study. So that is like over here, it's the proportion of downy section, how much downy section as compared to the entire feather length, or your basal metabolic rate, like we studied in hummingbirds, or the mass of the bird, or something. I mean, something that you're trying to study is usually on the y-axis. So that's the dependent variable, and the x-axis is the independent variable. So I mean, over here it's very visible that the downy section is dependent on the elevation. As the elevation increases, the downy section increases in proportion. But suppose there were like precipitation and temperature, like elevation and precipitation, sorry, not elevation, temperature and precipitation. Suppose temperature on the x-axis and precipitation on the y-axis. So as the graph, it should say that if temperature is on the x-axis, the temperature is the independent variable, and if precipitation is the y-axis, then precipitation is the dependent variable. So that would mean that precipitation is dependent, or as the temperature increases, the precipitation also increases. It's not the opposite way. It's not as the precipitation increases, temperature increases. Are you getting my point?
Yes, sir, I got the point.
Yeah. Okay. So that's the only.
Look, on the graph, just wanted to understand if there is any information about what are yellow points versus purple point.
I think you can read the paper, but I think
Okay.
there only there's binary. This is from Sahasa's paper, but yeah, I think you can read the paper.
I'll check.
Yeah,
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 thanks.
Okay, there's another paper, but slightly different question. I mean, slightly similar question. Sorry. Okay. So what the question is saying that the body feather total length is dash in aquatic than in terrestrial birds, and this difference between the group is due to dash plumulaceous feather, which is downy section in aquatic birds. Okay, let's see what the answer is. Okay, so there's a graph as well over here. What does it say? The plumulaceous length, which is the length of the downy feather, is less in aquatic and more in terrestrial. So that would mean that the body feather total length is shorter in longer in terrestrial birds, and it's due to the longer downy section, I suppose. Oh. Body feather total length is shorter in aquatic than in terrestrial birds, and this difference between groups is due to the shorter plumulation feather and downy section in aquatic birds. Are we clear on this? I mean, why downy section is more?
Yeah, got it.
Yeah, downy section is more in.
Sir, I have a doubt, sir.
Yes, Govind, please go ahead.
Well, my doubt is that aquatic birds are more likely to get cold than terrestrial birds since they are exposed to water more, right, sir? So wouldn't they be in greater need of downy feathers?
No, because they will get wet then.
Yeah, you got your answer.
Sir, but actually, in the case of eider ducks, which is found in the near the North Pole, these eider ducks, which the eider downs, which are used for all the bedding purposes and everything, they have a lot of downy feathers, and they are ducks. So, are they exceptions, or is this more generalistic approach?
This was based on some 290 species or something, this study. You can look it up, Pap et al. 2016, check feather. I mean, type also, Google Scholar did. Basically, check feathers or something like that. You will be able to find this paper. But
So
either
Yeah.
the,
But
the ducks
I
have the feathers. They have many feathers, but their length is very less because their
is this
plumulus is very less.
sir, if I think the length, if it is shorter, then it can be much more denser, no sir, densely packed in a place, like say 1 centimeter by 1 centimeter. Yeah, more feathers can be packed,
Yeah,
and
so the paper,
that can help in insulation also, no sir.
yes, the paper is talking about it. It's just talking about extra barbs and extra barbules in the feather and how how it is different among the different kinds of bird. But probably you should go ahead and read this paper. You can note it down if you want. But yeah, I mean,
The
there's a lot more to this paper than this little question.
the information from the lecture about the feathers and for the aquatic animal was that I mean, as I recollect, was that the interlocking mechanism for the panaceous feather is helping them being water repellent or resistant compared to the downy, because it will get wet and it is not so well structured, the downy part.
Yeah.
That's why.
Yeah, that's perfectly correct. So that's also explained in this paper. So I mean, I'm just encouraging you to go ahead and there are like only a few papers that I've mentioned over here. So go ahead and look at these papers once you finish with these lectures. So yeah. Okay, this is an interesting question. You're almost at the end of the talk, so there are two more questions.
A and C both same, isn't it? Increases.
A and C is.
EM
Yes,
increases, R decreases.
Oh,
it is repeated, sir.
okay. Okay, let's see what the answer is. But yeah. So definitely A and C are not the answer. So, did you get what this graph is talking about?
Yeah, hemoglobin level
Level.
based on the elevation,
Yes. And
and it increases as the elevation increases.
for which birds?
Residents, I think
No,
for both they are
both.
showing the same
Both.
thing.
Yeah.
For both they are saying the same thing.
Yeah, it increases for both the birds as the elevation increases. The hemoglobin level, which is basically what is how is hemoglobin calculated? The number upon
Did this.
12 gram per deciliter or something like that, right? That's the usual average hemoglobin level that human beings are supposed to have, right?
So what's up? 1 minute. I'm getting confused about what is being asked in the question. Are they trying to compare both the migrants and the residents,
Yes.
or in general they are asking what happens?
No, they're
If there
trying.
is a comparison.
Yes.
Then it should be constant, no sir. Like should be the answer.
No, 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 no. Why?
Because both show elevation. See, EM increases, R increases, but it is shown in the both the organisms. I mean, both the type of birds.
Yeah, so it
So,
should be D, no?
uh, no, sir. I'm asking if the question is asking about comparison between the migrants and the residents, or in general they are asking, sir.
No, it's asking
Between.
how does the hemoglobin concentration vary with increasing elevation in both EM and
Ah,
R?
here they are showing it's a similar graph, no, sir. Both are same, right?
No, no, I am just
So it should
asking
be.
how it is increasing in both. So EM, is it increasing? Yeah, I mean increases, comma R increases. So that's what I'm asking. Right?
Sir.
Sorry, sir. I'm not sure I got it exactly.
Okay, EM is elevational migrants. So
Uh,
how does
uh,
the hemoglobin concentration vary with increasing elevation in EM? It
I
increases.
got the question, sir, but I'm just not able to wrap my mind around. Are they comparing both the migrants and the residents, or they are migrating? They are comparing the birds against the what to say
No,
physiology.
I think Lakshmi, what you're mentioning is that in both the graphs, it represents similar change,
Yeah,
right, across
exactly,
EM and R.
exactly. Yeah,
But
exactly.
yeah, but the actual the question says is that is it actually changing in both the things or not? So yes, it is changing, and in a similar fashion, like EM also it is increasing with the elevation, and R also it is increasing with the
Then it's
elevation.
constant only. No, if it increases, this also increases. The increment is constant in
No,
both,
no,
right?
No, but
but
it's not
Lakshmi,
asking whether the
yeah, Lakshmi,
it
we are
is
not,
constant or
yeah,
not.
we are not answering, we are not asking if resident and elevation migrants are similar. We are just asking the basic question: how is the hemoglobin concentration varying with elevation in elevation migrants and in residents? So my options are elevation migrant, it increases; resident, it decreases. Option A. Option B is elevation migrant, it increases; residents, it remains constant. Does it remain constant in resident? Can you see the graph and tell me?
No, sir, it's increasing, sir. So it
Yeah.
should be D.
D. Yeah.
Yeah.
We are not comparing it like that. The question is very specific. Yeah, I'm sorry about the A and C mix up, but that's anyways the wrong answer. So
Sir.
yeah, who's this one? Who is this? Sorry. Govind.
Govind speaking, sir. So sorry to interrupt, sir.
Bolo.
I just have one doubt.
Yeah.
Both the graphs show a similar level of increase.
Yeah.
But shouldn't the increase in hemoglobin of residents be comparatively lower as compared to migrants, because since residents are already are resident in high elevation, the level of hemoglobin increase shouldn't be as high compared to.
Govind, can you answer this question now before you go ahead? Answer this question.
Okay.
Ruzbe, are you still confused? You said that you misunderstood the question. Oh, the correct answer was fourth. Hemoglobin concentration in both the elevational migrants and residents taken separately increases with the elevation. Taken separately, we're not comparing. Yeah.
Okay. Again, I misunderstood. But anyway, it's clear now.
Yeah. Govind, you're saying D, huh? Okay, let me just show you the graph and then ask you what it is.
According to graph, it's A, I guess. Sorry, not A. What was my option? C.
So you, okay. No. What did
It's
I?
basically increasing with the sorry.
Oh.
B is the option because here there is an increase in the elevated migrants, but it's got no effect in residents. That's what I was going about. I mistakenly
Okay.
did that
I
because
hope I am
uh,
not doing any mistake right now, but let's see what the answer is. But yeah.
So the x-axis is hemoglobin concentration, right?
Yeah, hematocrit.
Hematocrit.
Yeah.
sir, is this because the migrant species have to change themselves according to elevation? That's why they are showing that effect, while the residents one are living there itself, so they are used to the condition. Is
Yeah,
that because of?
and it also means that the residents are usually having a high concentration of hemoglobin in their blood. Elevational migrants, I mean, it takes time for both human beings and birds for their hemoglobin to increase the level of, sorry, for the blood to increase the level of hemoglobin in their, for the body to increase the level of hemoglobin in their body. But the resident birds usually have it higher than the rest. So you can see in the elevational migrant, so if I show you the, you can see in the elevation migrant the blood, the this level is at 14 at yeah, the usual level, and then it increases to 21, 22, whereas in the residents the level level is way higher than 14. It's like in 17 or something, which is generally a little bit higher than the lower elevation birds or even the elevation migrant. So that's, so let's see what the answer is. Oh, it is B. Thank God. Are we clear on this?
Yes, clear.
Yes, sir. Yes, sir. Yes.
Yeah. Okay.
Sir, I don't quite get this. Sir.
So, I mean, even, I mean, uh, so the hematocrit is basically if the blood is okay. We don't have much time, so I'll just finish these two questions, and probably you can go ahead and read the paper, Govind, if that's,
Sir, can I, sorry for interruption, can I just say in a small word?
yeah.
Birds or animals or any organism which stays in higher elevation, they have some physiological changes according to the oxygen content there, availability of it. So the blood is a bit thicker in those animals or species or birds which constantly live in those lesser sparse oxygen content area. That's why their hematocrit composition is thicker than the lower elevated birds. Those which living in the low foothills or much more lower areas.
Yeah.
I managed to piece together what I think is the understanding, sir.
But I would suggest you actually go and read this paper. It'll give you much clearer understanding. The entire session is not to just stop over here, and it's actually to encourage you to go ahead and read. So I'm just making your life a little bit harder.
Which paper is this, sir?
This is Sahas's paper. If you Google Sahas Barve, or rather Google Scholar Sahas Barve, this is one of the first few papers. Sahas Barve, SAHAS.
Is it given in the?
No, it's not given in the reading material.
Is it given?
No, it's not. But if you can Google Scholar him, you'll find him. Okay, so we started this question at 8 o'clock. So there are only two answers yet. We don't have much time, so I'll rush this thing. So there are three hypotheses that Anusha's study was trying to prove. No, three hypotheses that she looked at. The first one was emergency only hypothesis, which says that hummingbirds use torpor only when there's an emergency, when the energy stores are below critical threshold or something. The routine hypothesis is basically hummingbirds use torpor every day, doesn't matter what, when, just uses it. And the circadian rhythm hypothesis is basically an innate circadian response. So it depends on the day length and the season. So basically, it depends which part of the year the animal is living in. So that's the three hypotheses that is usually talked about when it comes to torpor and hummingbird using torpor. And the third is basically a two or more hypothesis being used. So the answer is it's not any particular hypothesis, actually a combination of all these hypotheses. So yeah, now you can see. So the thing is, the large territorialist hummingbirds might be accessing enough resources in the evening to avoid torpor except in emergencies, while for smaller hummingbirds that cannot routinely store enough energy to avoid torpor at night, the routine hypothesis could perhaps better explain their torpor use patterns. But there are exceptions when it comes to migrating small birds. So are we clear on this?
Sir, can you just read it once again, sir?
So it depends on which hummingbird you're talking about. If they are large hummingbirds, then they might be accessing enough. So they have enough body stored fat, say for example. So they have enough. So what they do is they might be accessing enough resources in the evening to avoid torpor except in emergencies. So they have enough body fat. So all they have to do is in the evening they forage a lot, forage a lot, and that's enough for them to spend the entire night and be alive in the morning basically. But in the smaller birds, the smaller hummingbirds, the probability of it storing enough fat to last it the entire night is less. So that's why they have to undergo torpor daily. Are we clear on this? Now?
Oh, yeah, I understand.
So there's not one.
There's not single one thing which can explain this. It is a
everything.
mixture of couple of hypotheses.
Exactly. So let me just go to the last. Oh shit! What did you do? Oh, the answer you've already seen. It's okay. So this is what I was talking about when I was saying the mass specific relationship with the energy expenditure. So this is a particular hypothesis that says that metabolic rates as a function of mass are expected to scale. So there is it depends on the taxa that you're talking about. There are like specific relationships between the mass and the energy expenditure. So yeah, so it could be surface related, like in some animals, how is the so surface related is basically heat or water flux, and volume related is basically related to activity. So how is the metabolic rate dependent on the mass is basically how is the energy expenditure happening. So is it, if it's energy expenditure or energy absorption or whatever. So if it's heat or water flow related, then that is a surface related process. Then the do you see the relationship over here? The log of daily energy expenditure is equal to, this is some constant plus 1.21 into log of mass. So this 1.21 is basically the slope. The answer is 1.21 basically. 1.21. This is what was the previous this is the relationship that was calculated in the laboratory experiments that was done on hummingbird. Anusha had done furthermore experiments, and she found the relationship to be not as high as 1.21 but much closer to 1.95 basically. So birds usually have this relationship as 0.67, and volume related processes are closer to 1. So what I'm just trying to say is basically in nature everything cannot be regulated by rules and thumb rules, and like just one fits everything. Like the last question we saw, one theory cannot prove everything. There were like a combination of the theory hypothesis for different sizes of birds and etc. So same thing is over here. The theory says that 0.61 is something that goes for all the birds, and one is 6.5 or 6.4 is something that goes for all the birds. But that's not true with hummingbirds. It's the number is 1.21, and Anusha's latest paper, 2020 paper, says 0.95. So I suppose everyone is, yeah, that's the gist of the paper. But yeah, you guys can go ahead and read the paper further to know more. Yeah. So this was the last question. Are we okay? Are we good? Can I say goodbye?
Sure.
Yeah.
Thank you.
Sachin.
Yeah, thank you.
No, thanks.
Okay. All right.
Thank you, sir.
Thank you.
Thank you, sir.
Bye.